We now come to the discussion of conservative and non-conservative forces. So what we'll do, we'll put a division here, and then we'll discuss the conservation separately. Now, the first thing is that for conservative forces, the first point is that they comply with the conservation of mechanical energy. So that is very important, that they comply with the conservation of mechanical energy. And the non-conservative force that do not comply with the conservation of mechanical energy. Now the point remains that how is it that it do not comply with the energy conservation? So you have to understand in that case that it complies with a greater spectrum of energy conservation, which we call work energy theorem. So it should be made very clear that though theoretically we suggest that a conservative force complies with the conservation of mechanical energy, and a non-conservative force, it do not comply with the conservation of mechanical energy, but that non-conservative force complies with a broader spectrum of energy conservation, which we call work energy theorem. Now the second point remains here that for conservative forces, the work done on the system gets converted to potential energy. So that is very important, that for conservative forces, the work done gets converted to potential energy, and that potential energy in calculus form can be put like this. So it is fundamentally nothing but the work which you are converting it to potential energy. Now, for non-conservative force, the work done can be converted to both kinetic energy and potential energy. Now, that is very important, that for non-conservative force, we can have both work done get converted to both kinetic energy and potential energy. Now, the third point, as we can discuss the third point remains that in a closed path. Now, the third point, as we can discuss here, is that the work done in closed path here is zero. So the closed path work is zero. That implies that the fact that the work is based on displacement. So you start from here, you go on various paths, and then you come back to a particular point. In this closed path, the work done becomes zero as the displacement is zero. But here, very importantly, in closed path, the work is not zero. Why not zero? Because this work is based on displacement, and this one is based on distance. So it's very important that the closed path work is not zero, as the work is based on distance, and here it is zero as work is based on displacement. So I want to make it very clear, these two parameters of distance and displacement. Now we need to know the examples of conservative forces. As you can know, the conservative forces are gravitation force, which is a very important conservative force, and then we have Coulomb force, that is the force of electrostatics force, which we know as conservative again. Now for non-conservative force, you can say that all kind of resistive forces are non-conservative in nature. Now, the non-conservative forces in nature consist like friction, which is a very important non-conservative force, and then we have air resistance, which is again a non-conservative force. So this kind of viscous drag, so all this kind of, opposition forces are examples of non-conservative forces. Now, for non-conservative forces, the most important aspect is that we use to apply the work energy theorem to solve this equation. And here we need to apply the conservation of mechanical energy to solve the system. So this primary division of conservative and non-conservative force is very important for our further studies in work power energy. So that's all for now. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.